Good morning, everybody. We're at the final part of this wonderful conference. And my name's Cliff Jacobs. I am the moderator of the panel. Some of you don't know me. I worked for the National Science Foundation for 30 years and did research prior to that. What I would like to do is maximize the time to get the answers to these questions on the screen up here. So everybody has heard the wonderful presentations from all of the PIs here. So we're going to just skip that. And what I'm going to ask them to do is to respond to, I'd like to start with the second question, and I'll tell you why in a moment. But if they just say which project they were part of and then begin to answer the question, I think that would be the most efficient. I also recognize that some of us have airlines flights and we have to leave early. So I want to make sure that I know for sure you might be the first responder, but we're respecting your time. And the reason I'd like to start with the first question is because I still can't get rid of my NSF hat and wondered whether when these awards have made, they've all made great progress and they accomplished that in different ways. And I'm wondering whether when you started thinking about this project, you had all the experience to now, and you've had some different views of how the future of the HDR would progress. You've learned a lot. And to me, I always care about the fact, what did we learn when you fund something like this? Each one takes a different approach. You hope they're all successful. And I think we're going to learn a lot from that. So I will start with that first question about what is your views now compared to what they actually were when you wrote the proposal? What did you learn in that process?
You mean the second question?
Yeah.
Yes. Okay. Hi, everyone. Still Tanya Berger-Wolf, Imagamic, representing Imagamics Institute. There are two things, I think, and they kind of go in the opposite direction. I was thinking about what did we learn when we were writing the proposal in the middle of the pandemic versus like how we think about all of this one now. And I mean, the elephant in the room, all of us, one of the things that also happened, not just the pandemic, but LLMs, right? Gen AI and LLMs have happened in the middle. So that has changed things or not. So the kind of, on the one hand, the big thing that we learned when we were writing the proposal, we're like, oh my God, can we even do it? Can we get to the point where we're saying like, oh, this is the species because, or this is doing this function because, like, here are the traits, to discover some traits that humans have not seen, have not observed, have not realized. And when we were writing, a lot of biologists, weirdly, a lot of scientists were skeptical that AI could do this. Today, there is nobody skeptical. We're way on the other side of it. Like, I'm having some conversations where we're like, well, just a limit. I'm like, we don't have the data. Well, can't the AI just produce the data? I'm like, whoa, like, no, right? Absolutely not. And so we've gone, but that actually, these conversations were about a year ago, where AI can do everything. And this, even in this last year, we've gone through AI can do everything to this is an overhyped, resource guzzling industry, and I don't want to have anything to do with it. So I was just at Ecological Society of America last week. We were giving plenary, doing tons of workshops and sessions and panels on AI, different aspects of AI and ecology. And there was also and I have a picture of it, I actually should have put it, a kind of whiteboard with how has AI changed your life? Prompt. And people were like just using markers to write things. And most of them were negative. And so I think in this like cycle of investment, we've gone from like, can we, like, this is ambitious, can we do it, to then developing these methods that are not LLM, that are not Gen AI, but everybody's saying like, oh no, it's AI can do it. To now coming to a realization, no, AI cannot do it, and shouldn't, not that kind of AI. We still have a job to do, but it is actually super feasible. We are now coming to the point where we just all of us, I mean, I've heard all of the talks, all of us are on the cusp of like true scientific discoveries. We've finally built up the tools. We've finally built up the infrastructure. We've finally built up the understanding to deliver on the promise of the proposals that we were writing, to do those scientific discoveries. And I feel like we're like a little bit of a punch that just as we're ready, we're out of air, right? So that's kind of the one side of what has changed. The other side, and a massive understanding that kind of aligned with it, is there is no AI without data. What enabled all the AI revolution, the AI institutes, the massive hype of AI is us, is harnessing the data revolution. And we still have lots of work to do to harness data, to build AI-ready data infrastructure, to build it in a way that enables the answers to the questions we want to ask. Not just, okay, let's go and digging in the data that we have, we'll find something.
And thanks for Tanya. This is very nice opening. You literally covered down most of the thing I want to cover.
Oh, sorry.
Yeah, so that also just shows that even in activity 3, we focus on the 3 domains, the baseline, physics, astronomy, and neuroscience. But we just share a lot of the challenge in common in biodiversity and in Arctic data and GIS and in even in the theory part for the material science. To me, I want to comment on my personal thing I learned while we write this proposal. It's interesting process that I usually just work with people in my field, physics, but because of the HDR, because of the proposal, I have to step out to understand what interdisciplinary collaboration truly work. Yeah. And this is also one of the major things I learned through the past few years of operations. So you need to keep an open mind and to listen to challenging part of the field and using a different angle then to find the commonality between different approach then and eventually you can collaborate. So these are the most of the thing I learned. And the challenges we saw have been many of these. I have to agree that LLM and generative AI really bring a side of solution for that, and many people are excited about that. But it just help us to face to the frontier of the science field we are changing here to deeper to another level. So we currently have to think about after these years of operations, we all build beautiful tools that we deliver the science we wrote in this proposal, and we are ready to go bigger and how we could make this happen. I think this is probably have to require me to go even more open mind, go beyond just the 3 domains we have. Yeah.
So you just heard from me. I don't have this.
Yeah.
You work on your exciting stuff.
Yeah, it is.
Hello?
Yeah.
Okay. So you just heard from me a bunch about iHeart. So I'll say a couple of things, and I think we all will echo many of these things that you're hearing. When the proposal was initially being written, I was department chair, and I think I remember the main focus was just making sure all the right people are on the team, bringing in the right people. We thought that having the right people, the right water scientists, and the right community would help us get to the data. And it was clear that there is data. But as I was talking in my data story, What we quickly realized is not all data is ready, not all data is adequate. Not, it's not that it's not collected, it's just not ready for us to use. And building those tools rely heavily on the data. So through the years, obviously, we've been able to create these tools and data sets. But even today, the good data quality is hard to find, and we constantly go back and forth on that. On the other hand, I think there's an operational side to running an institute. It's really like being a department chair again, and making sure that all operations are running fine. And when you do all of this and you build this amazing community, it's important to sustain it. How do we sustain it, right? So I don't think that it's automatic and we can say, well, the community will come together, but there has to be programs like these that keep at least the community sustaining. And the last bit I'll say is, it's very easy to say that AI will solve all the problems. It won't. I was hiking through the Pacific Northwest this past few weeks ago, and it was just amazing to see my phone won't work, my email won't work, the chat GPT that I was used to will not work. I was still relying on paper trail maps, and it was just amazing to see that geoscience in many of the communities is still on the ground. So there's a huge leap that still has to happen, and I don't know. I think when we write our paper, we have to communicate to NSF and other agencies that there needs to be continued investment to bring these communities together and make that leap from science to the ground. The science that we are doing.
I think a lot of great points have been made. For those of you who do not know me, I'm Xiaowen Wang. I was earlier part of the program representing my guy. I'm also the primary guy responsible for your alcoholic drinks. So yeah, to build on what was said, I think the thing I learned, which was not so deeply appreciated when I was writing the proposals, was the people part. To bring people from different communities with the different incentives and the backgrounds together to actually act on the same page. I would say I underestimated how much the challenge was. Not because the proposal was written during the COVID days, but just because how hard this is. And I think to NSF, given the progress we have made, I think this might be the most valuable part of this enterprise going forward. The people have been brought to this convergence ecosystem. And if there will not be funding sustaining this community, it would be a huge loss of the reward coming from investment is actually what people want. So that's, I think, the first point. The second point, because Cliff was on the external advisory board, I learned from him and other members of the board is how do you demonstrate the whole is more than the sum of its parts. And this is obviously oftentimes focused on science, and clearly all the 5 institutes are pursuing convergence science, meaning how could you demonstrate scientific progress could be achieved through this approach? And I learned this is not easy. This is a very difficult show. Convergence is by intention, or it's by accident, or it's by coordination. And why these institutes are coming together the way we have been doing our work, actually not just correlated with the results. We're sharing, obviously, we're all excited by the progress, but actually by the necessity of this investment. So that's the second thing. Obviously, there are really, I think, strong evidence, results, progress along these lines. But I learned not in a sort of straightforward. I think there's good set of insights that could be gleaned from this learning experience. The final point I would make is, how, much synergy across the five institutes. I've learned, obviously, this is, you could say from my perspective, the pleasant surprise. At a very technical level, at least three institutes are dealing with geospatial data, as we're part of the geospatial data revolution. And all five institutes are actually taking critical spatial thinking into their work. You know, we were talking about them, or, you know, thinking creatively, across spatial representations from molecules to, the universe. So that's just the intellectual, very basic, commonality. But beyond that, from the technology, of course, from the current science, elements, so just incredible synergies. And I think this should be recognized as well as appreciated by NSF, because if they invest in a community like this, probably amplify the fact that the synergies are really powerful to, especially prepare for the next generation. That's not it.
Yes, okay, I think most people have said a lot of the things in my mind also, I will echo that a big part of what I learned is the time and the investment it takes, and I think what has been really special is that this opportunity created a protected space for all this time to be, for us to be able to bring different communities together and have the time to talk to each other and learn and understand each other's problems and come up with new ideas as a result of that. And that protected space is rare and special, and I think it really should be something that we find a way to promote and continue. It's not easy to do these things, but what, you know, I really echo what Xiaowen said about the people being important and finding it. We always said in our leadership team, we have great students, great faculty. Let's put them in a room together. Let's seed some ideas, have some conversations. And seeing how people really took that opportunity and kind of rose to it because they genuinely wanted to and were interested in each other's problems. And the computer scientists and applied mathematicians got excited about many body physics and quantum mechanics and materials, and the materials people got excited about, I would say more than, you know, plugging in some model from some software package, but just actually trying to understand how the methods worked from first principles. And I feel like we just ended up creating this group of students, faculty, whose perspective has really changed as a result of that. And seeing that evolution take place, it's been very rewarding in many ways. And I think that, you know, in terms of finding ways to promote and let that keep happening, I think is most important. This is a really, I mean, it's an exciting opportunity. It has been exciting. It continues to be. And I echo that. I think a lot of us feel like, wow, we're just getting started. We want to be able to keep doing this. We want to be able to keep thinking in these non-traditional, out-of-the-box ways. And it's not only great science, but great fun. And I think that it does result in producing a different mentality. So I'll just kind of echo that observation quite a bit, and say that I hope that that's something that is understood by
by NSF. I hope it's something that's understood as like, this is something that we find very valuable.
Add a number to this. I want to add a number to kind of the people side of things. Yeah, we're all building scientific discoveries and tools and infrastructures. Amazing. For the people side, among our 5 institutes collectively, we have over 1,000 researchers in science and engineering, right, collectively. And that, again, that are part of core, part of the community, part of those who've been trained, the next generation, over 1,000 in just 5 years. And as by SF report, every year there is 45-ish thousand PhDs nationwide that are awarded in science and engineering across all of science and engineering. 1,000 actually is a large number compared to that. It's not a negligible thing. We're building truly a community that is not represented anywhere else.
Let me follow up with this. First of all, you confirmed what I suspected, that there was not a straight line between point A, when you wrote the proposal, and now. It's been a very interesting line, and you helped us understand that. Also, as an observer, I think you've all produced very interesting stuff. But the one uniform thing that you really helped with is workforce development, big time, and the publications that have come out of your awards. And the publications are important because in the ecosystem of the university, this is important. But you also look now, and I'm going to ease into that first question, is, okay, there's this galloping pony for harnessing the digital revolution. And we understand industry is spending a lot of money, so is the government. There is a role for the universities in this, to stay on the back of the galloping pony, to actually make a contribution. What do you think that the role of the university is in this very fast-moving environment that we're in right now?
Yeah, I think that's a very important question, and I think that it's sort of gonna tie this a little bit back to what we were just talking about, which is this idea of the universities serving as the home of these protected spaces where we can work with students. We can, yes, do workforce development, allow them to explore, allow them to learn the basics, learn to become good contributing researchers and critical thinkers and scientists, and do that in a way that is I want to say this the right way, but somehow free from some of the things that will constrain your life when you go into industry, free from being tied to a profit motive, free from doing things in ways that are very fundamental and important. And we understand that a lot of what develops at the university stage, only some of those ideas maybe ultimately get translated. We want more of them too, but the ones that do end up being very impactful and powerful, and just recognizing that that's the process. I mean, that's how developments and new ideas kind of emerge, is having that. I think we've had that understanding of the different roles for a while, and I do think a lot of what we've heard about, partnerships with industry and universities, I think these are very exciting and good opportunities. I would hope that this is done in a way that is thoughtful and remembers the mission of a university as well, in terms of workforce development, education, letting students be students and trying things, having the opportunity to. I look at our HDR students, and it's funny, most of them are, I think they feel like they're co-advised, and they're co-advised by their main advisor at their university, and then somebody at another institution who they get on Zoom meetings every week. And they just naturally do this. And so having that space is super valuable. In a world where, I go to my material science conferences now, and this is recent, all of a sudden, I see, I all of a sudden I started seeing people from Google and Microsoft showing up, and it didn't used to be that way, but they're there now, and they're building in-house data sets, and it's actually good for us, I think, in the universities in many ways. They bring a new perspective, they bring a different thinking. And that challenges us in a lot of ways. But it also reminds me to think about what our strength is and what it is we can do and think about it. Some of the, I think, ideas that I tried to share during our presentation, I kind of wanted to highlight that thinking that we brought when we were able to spend time thinking about group theory and symmetry and machine learning and how to combine these in ways that are that really require both dedicated domain and data and probabilistic modeling in ways that would have been, hard to merge otherwise. So I think keeping that in mind is important. Yeah, I could go on, but I'll stop there. So.
We're going this way?
Yeah.
Okay, yeah. Can I agree with, what Alec has already, explained about the, I'll mention.
My closer, just closer to him up.
Okay, yeah. Very quickly, just 3 points. First, I would say, university is well positioned to do foundational research. Compared to what industry is doing, especially in this very, dynamic. Still closer?
Yes.
Wow. Especially in this, very evolving environment, of changing funding landscape. I think industry we know is really powerful in what they do. And a good example there as a comparison is, you consider industry, for instance, doing research to, really get planes to be, rollouts and, scalable and, ready to go. But the universities in the context of creating the next design of plane, as opposed to also, building planes as industry, has been doing, at scale. I think the second point is we need to recognize, because universities highly involved in, preparing the next generation, the workforce, which actually is going to industry. So I think we need to be thinking in the way that the workforce going to the industry requires scientific rigor. So it's not supposed to be driven by shortcuts, by various factors beyond science. So we are in the university preparing the younger generation with the scientific rigor needed. Once they get into the industry, they can apply that rigor and the scientific thinking and foundation for the work they're doing. So the third point is the university is also well positioned for fostering work that spanning boundaries. Again, this is in our education system, not institutions are doing this in a uniform way, but I think for especially this community, what we have learned is how do we do that at universities that could really help promote convergence. So those, I think, 3 areas could be more tied into what a university could do well compared to what an industry does.
So I think we are in a very interesting place to rethink what academia's value is. And we would all love to wake up, 2028 and things back to the usual as they were. It's not gonna happen regardless of what year we are in. We are seeing that all around. So it's a very important question. In terms of the research and industry's value, we do have to partner, we do have to show impact, and we do have to show partnerships with industry. But that's with a caveat. What do I mean by that? So I'll give you an example. In 2016, Jeffrey Hinton made a claim that you will not need radiologists. AI will look at images and X-ray images and tell you everything, and you don't probably need radiologists. In 2026, when they revisited that claim, today there are more radiologists than there were in 2016. So there are some claims that have value, some claims that don't. And I think we have to take everything with a grain of salt. When we look at the AI use and availability in industry, there are bands. There are some industry, sectors who have the most available AI cycles, and they are just leaping ahead. There are others that don't, right? So there's a whole, swath of experiences there as well. In terms of academics, we are not solving just a big business problem for today and re-engineering the heck out of it. We are solving foundational science for that will propel us for many, many generations to come. And that's how we should be thinking about it. Interdisciplinary science is not a traditional business problem where you have one spreadsheet or one type of spreadsheet or one type of customer. It's a lot of different things coming together. Each of our problems, each of our institutes solves those problems, right? The interdisciplinary problems. I think the value of academia is really in those interdisciplinary spaces, and even in disciplinary spaces where you're really looking 10 years ahead, leaps. The place where I think we need to show our value is telling our stories. Now, imagine the brains that we put behind solving, Nobel Award winning research. If you could put that same mind to telling our stories better, I think that would make a huge difference. We have not done a good job at that. I don't know if you all know, but the LASIK eye surgery was accidentally discovered by a graduate student who was working late in the lab, and he messed up the instrument and it went in his eye and it ended up with an accident, but discovered LASIK eye surgery. I'm not saying that we should all do that. You don't want to have accidents happen in the lab. But my point is that when you have graduate students with time and with motivation, they will discover things. But are we telling those stories right? How many of you know about this LASIK eye surgery story? Or how many of you know about the Google story behind it, how graduate students worked on this one paper? So I think that's where we need to show our value and impact.
So I try to recall what happened recently from my industry friends. They asked the referral. They are looking for students, good students, who are not just using cloud or Gemini or any kind of AI tools to cook out their work, but they really understand the domain knowledge behind. I also look at the engineering students in University of Washington. Just a small sample. Might not generalize to nationwide, but just look at what happened. Students have a challenge to look for a job, while they used to be just easily get a job before they graduate. The interview process really in this big company, we talk about IT company, Google, Amazon, and Meta. They are looking for people who are not just have the knowledge or the technical skill to solve within a well-defined problem, but they are looking for people who can think cross the discipline, cross the boundary that beyond the boundary that can solve the more complex and real world problems. So where can you have the education system to grow such workforce? And that's the university. The industry will not spend their money to raise inexperienced people to grow, and they would like to spend on people who can bring more productivity results for them immediately. So university will maintain this role to create a workforce and provide the this high quality personal power to the world, not just for the industry but also for the academic. So I think this will maintain true and even more severe. But the way that we train students in university will change because it's so easy to get answer and from the AI. And if I just look at the young generation that students who do the project, they can turn in the project so easy. And but it's not necessary it's the correct or valid result. So we are talking about AI literacy, how we really train young generations that how you should learn using the new tool to learn better, but not just as a general result, but really as you can use AI to train your thoughts in more critical thinking, produce your result, put into the AI, and then ask AI evaluate or change me back. So it's a habit we want to train the young generation to learn. So also the ethic is really important. How you can use AI, but try to amplify your original idea, but not just clone or accidentally just steal other people's IP. So these have to be trained when you are in an environment and you allow people to point out some mistake you made, but you still feel safe. And that's university's role. So I think more closer partnership with the industry and university has been reviewed right now. And in university, usually students will not determine their majors when they are freshmen. And then they will decide their domains. And when in the end of freshman, they step into sophomore, junior. But the trend could be in the directions and more encourage on minors or double majors. It become possible and easier for people to do because using AI, you are able to learn, accelerate your learning to extract the domain area easier. So I think in summary, I would say university will continue maintain the important role to train the young workforce through AI and partnership with industry that we want to really emphasize the AI literacy and our ethic. Also, we will train more students who could go across the discipline easier.
So it's interesting that the biggest kind of differentiator is the mission of a university is to educate, which is absolutely true. I'm also I spent my entire career in public universities, most of them 9 grants, which have that mission to educate. I'm also I think I'm the only one who coming from the core AI side of things, the development of AI. But I'm also kind of the background that I bring into this. I'm a multilingual immigrant, as here, multilingual immigrant many times over. So that brings a very different perspective of ability to translate between frameworks, between value systems, between expertise with their limited vocabulary, but also recognizing the humility that my value system may not be your value system. And I think all of it is coming to play, not just in interdisciplinary research, but also in this context of the explosion of AI from a niche methodology to being part of everything in our lives. And there are people who are saying that, like, on the one hand, that AI will bring the dark ages of science, and because nobody will care to need to understand anything anymore or learn anything because AI will do it. to the other extreme that AI will bring the enlightenment age of the society because it will enable us to do everything and understand everything and use science. The truth is obviously in the middle. But this conversation about sort of particularly from the AI side of things. So what's different in academia? What's different in AI for science and AI in academic setting versus AI in industry? I mean, there are two things that I would push back on this. One is, yes, it is the education. That's the university mission. But also, especially in public universities, our mission, and more broadly in science, is not just to produce solutions for industry, right? We work with partners. Our partners are not just industries. Our partners are civic societies, our government organizations, our nonprofits, NGOs, and so on and so forth, educational organizations, right? And so AI as an industry is by far the minority partner is in everything that we do. And they don't even show up in most of our partnerships questions or whatever. So there's a lot left to ask. And the other perspective as social more broadly as an industry, they say that in tech industry, there are two V's. There is the engineer's V, which is viable, and there's the business V, which is valuable. And I would add that the research, the academic V is the visionary. And those two, there are different value and priority frameworks behind each V. The valuable for industry as in like it has to produce money, right? The viable for the engineer who creates this model and the visionary for the scientist. They intersect, but there is a massive space where they live with some alignment to other value systems, but we have our own value system, and so the type of AI, the type of work that we produce is very different, is visionary, occasionally, I mean, sometimes mostly viable and occasionally valuable.
Can I add my 2 cents to this? Essentially, I'm going to draw on my experience in different fields, but I think, one of the things that I think is that I've heard all of you say is that in this, the university environment is embedded in a much bigger society, which is moving very fast. And it seems as we get older, that moves even faster. I'm not sure that's our age or whether it's really actually happening. But the main point is that I think the universities have to defend, it's incumbent upon them to defend the interests of science and workforce development in a rapidly changing environment. And by also maintaining the integrity of science, which is reproducibility, for example, ethics and other things like that. From my broader point of view, I see this as an important role of the universities in a very, very fast-moving society. Keep your voice going and make sure that it's heard widely. You'll be able to contribute in one way or another, but it seems to me that you can't drop out of the game at this point.
We're holding the tiger by the tail, and we'll keep holding on.
Okay. So we covered that. The last question, and perhaps you want to add more to those questions. That's certainly great because we've already heard some really interesting answers now and a lot of different perspectives. Success has, for all of you, have been there, and it's come in different ways. Always not quite sure how you achieved it, but I think you gave us a little insight into how you achieved that. The last question we have here is, how does this Harnessing Digital Revolution Institute impact science and society? I think you touched on a little bit, but maybe you want to answer that a little further.
I'll do short. Let's not get it. So we need to go. I think all of us show the scientific discoveries that harnessing data revolution frameworks have enabled. All of us show the next generation, building the community of current interdisciplinary scientists and training the next generation. But what also struck me, especially when Xiaowei was talking, is that it changes your mindset. And I think one of the biggest impacts, we can talk about the scientific discoveries, we can talk about the adoption of methodologies, of the use of our models by our organizations, or the number of downloads or whatever, the number of students graduating. We all have those statistics, but I think the shift, and I would say that yes, AI is moving fast, but there is a reason why this community is adapting faster. I think part of it is because the mindset is different. Because we've heard stories of interdisciplinary scientists who had to start learning to think sort of outside of their comfort zone or disciplinary zone. The first time you do it, it's uncomfortable, it's interesting, or it's challenging. The 10th time you do it naturally, and it actually changes your perspective. You start seeing and looking for this opportunity, like Xiaowei talking about that, you have to do it at the beginning. And now the second half of everything that you said was about looking for these connections, generalities, cross-cutting themes. We all now do it naturally. It is a different mindset.
The HDR for impact is definitely through research interdisciplinary cooperation, but I think each institute have a slightly different approach. But I think we all are able to achieve a goal, like we are growing the community, go beyond just our original domains. Yeah. And one thing I really value is when I first have our first ecosystem conference, I look at the iGuide Xiaowen's version, that I realized, wow, even in science, we could have actually built a strong bonding with the industry partners. So we learned quite a lot, like how iGuide approach, and in SCPC we also try to reach out and building a partnership connection with the industry. Yeah. So this kind of align to the current trend of AI. Yeah. Part of it, because the AI technology is really accelerated down by the industry, that we have no choice, we have to catch up. But we are now just not catch up, but we can be part of the player who shape the direction for the technology. Then we learned quite a lot how imageomics and really the field trip that really impressed me, like how you actually can organize and all resource to collect the unique data on the web. And in physical science, we try to collect data from the extreme environment in collider from the universe. But how we could actually make it be even more fun, accessible to public. That is really impressive how I see economic data. And in many sense, like our challenge is very similar to iHeart, because we are all doing extreme data. So you are able to get 1,000 high school students to play and to analyze your data. And this is really just for me, it's mind blowing. Like, oh, give us the idea that HDC could also try to do that. So I think HDR ecosystem for this version, even without us with this platform, it's not naturally happening for me to accept all those information. Yeah. So I think the foreign impact among us and also go through, and maybe our next slide is also invite the artist or architect to formulate our the data to make it be even to a larger audience. So this is the just not internally our impact, but also go together, we can have a bigger influence.
That's a very nice summary, I think, of how we learn from each other, and the ecosystem was really amazing. And we've seen that every year. And I think I can think of several applications that we've developed in iHeart that are contributing directly to polar science, and they also have generalizability to other domains, especially to fine grain annotation and so on. But I think if I have to leave with one thing that our HDR students, and I think all of ours, has contributed is training of the next generation, is training of the students. And training is a very weak word. I remember one of my students, she was working on an interdisciplinary project, and she was very frustrated talking to the two domain scientists. And she said to me, "This is very hard. I cannot do this." It was so funny to like get her through that, because she was really making progress. And now, 2 or 3 years later, she's getting ready to defend and really done amazing work across disciplines. And recently I told her, you should go and check with our domain scientists, what they think about this outcome. She was like, yeah, I already set up the meeting. So I think just that natural thinking that they are developing, and it's amazing to see them extract some AI knowledge here, but abstracting it out to how the domain will be impacted, or how they should look at the data differently, and how they are making these leaps of understanding, and how they're explaining it to domain experts and receiving that knowledge back. I think that has personally been a tremendous joy to watch the advancement of our students. And I'm just looking at our students, I'm really proud of our students, how they have done these things. I think that's the biggest benefit to society, because if you really want to see new advances in AI and how AI is being used, that's going to be in multidisciplinary spaces. And if we don't have researchers who can understand multidisciplinary spaces, the soft and messy parts of it, you will not be able to advance. And I think that's what our students are doing, is really learning that messy science. It's not all this.
Yeah, first of all, I will say, have been really impressed by the work done by the other institutes. Of course, I got included in this ecosystem. Just cannot believe how much has been accomplished within less than 5 years. Well, the number 2 point is I see an opportunity from the IGUIDE experience that we could now approach a new way of conducting science. An example there is within IGUIDE, you would be able to now access the knowledge produced by IGUIDE completely online. More than 80% of the publications, data sets, models, and educational resources, software codes, these are accessible. In the past few years, we stopped asking our team members to submit their publications, the list of their publications to us. We basically tell them to the IGUIDE platform to contribute to knowledge elements there. And these knowledge elements are interlinked across different communities. And it's searchable and fed to AI. So you might have heard from Chaitan Baru, or NSF, United NSF program officer, talking about the new way of knowledge dissemination, publishing. I think from that little example, I see a tremendous opportunity from this community. We could put forward a roadmap for the next step of the ecosystem. Say, hey, there's a potential new way. This is what's reflected from the harnessing the data revolution for new knowledge production ecosystem. So I start seeing that potential from IGUIDE experience and also similar experiences from the other institutes. The third point is translation to impact. A few examples from IGUIDE. There are actual stakeholders and the users from society getting access to our tools and technologies and the methodologies. and aging dams, safety matters, and emergency responders coming to us to see how the capabilities coming from our project could be used in their own practice. And coastal flood zone planning, 10-year horizon policymaking is taking our methods into their planning activities. And the United Nations Sustainable Development practices are citing our work. So I think this is the one way we could connect scientific work to the broader societal benefits. And this is where, for instance, the TIP director is looking for. So how do you turn your science into actionable linkages to what society is looking for as guidance?
It's really, I mean, it's very nice to hear, wonderful how all of the institutes in their areas have been successful and really made an impact, and it's motivating and inspiring to listen to the stories. I think impacting science and society. So the tools that we've developed, the simulation tools, that are AI accelerated, or some of the things I was showing with generative models, those have been, they're being picked up by industry and startups. We've been contacted, and we know they're using our models. We have visualization tools that have been developed in our within our institute that our startup company Collaborator is now using in their automated materials experimentation platforms that they've been building. So we see some of these impacts. There are, yes, the methods, the tools that we've actually made, and the adoption that we're seeing in them. I guess that's one. And then two is our students. Again, we've talked a lot about this, the researchers that have come out of this program. And we also see that they get recruited. They are, after we had a student graduate who was pulled by a startup company and then tried to get somebody else trying to poach him. So I think that the next steps after grad school, where these students go, I see, it's clear to me that their skills are valued, and they're sought after, and so that's nice feedback. And then I think the final thing that I'll say is, I think we created a new way of thinking about how AI or ML methods should work and should look in a physical sciences context, right? In a context that is different from natural language processing or computer vision, or where things look a little bit more like a learned inference than a traditional machine learning type of application, and ways to bring physics together with statistical learning approaches that can be powerful in and of their own. That translation, I think, is another contribution.
Well, thank you all for that. I am actually going to take the opportunity to end this session because some of us had travel plans. There's a bit of exhaustion also, including the moderator. So, but we got insight that I don't think we've got any other time in the conference. And it was really, really valuable. And it helped everybody here, and certainly helped even the PIs among themselves. So we know it was recorded and it's worth looking at, but I want to thank the panel members and let us end a little early because they really have made a major contribution, not only in their awards, even in this session here. Thanks so much.
Thank you. Thank you. Thank you all.